Okay, today we're going to talk about dilations, which we've mentioned already. You guys are a little bit familiar with them. Just as a refresher, dilations have to do with a change in size of an object, but the shape stays the same. If we make something bigger or enlarge it, then the scale factor is greater than 1. If we do a reduction or make something smaller, then the scale factor is between 0 and 1, also known as a fraction. Could also be a decimal, but we usually use fractions. Okay, so when we look at a picture of two objects, we should be able to decide if it's an enlargement or a reduction. So I want to draw your attention to these little tick marks here. If you remember from our previous lessons, this is called the image, which was created from the pre-image. So if this was our first image and this was our second, we went from here to here, that means our object got smaller. So this is a reduction. The next thing we want to be able to do is decide on the scale factor. So how much smaller is it? So we started at 6 and we ended at 3. So we're looking for what we multiplied by to get from 6 to 3. And you can do that. You can think of it like 6 times the scale factor equals 3. Divide by 6. And we get that the scale factor is a half. So it works for all the sides. If we look at the 6 to 3, that's half. And we can look at 8 to 4. Also in half. All the sides would be, we just don't know this hypotenuse here. Okay, so here's one for you to try. Go ahead and pause the video. Give it a try. All right, let's see how it went. So first you had to decide if this was an enlargement or a reduction. So hopefully you paid attention to our little tick marks here, meaning this is our image. And this was our pre-image, meaning we went this direction. So we started at 3 and we ended at 9. So that is at times 3. You could also say we started at 4 and ended at 12, also times 3. So we have an enlargement with a scale factor of 3. Okay, so the real new part to this lesson is being able to do this on a coordinate plane. So here we have a triangle ABC with points 1, 1, 3, 0, and 4, 3. And the directions say that we'd like to dilate the triangle, this one, ABC, about the origin. So we'll talk about when you dilate something not about the origin in a later lesson. And we want to do this by a scale factor of 2. So is it going to get bigger or smaller? That is an enlargement because it's greater than 1. And this isn't that complicated. We're going to take each of our points from the pre-image and we're just going to double everything. We're going to multiply them all by 2. So our 1, 1 point, 1 times 2, and 1 times 2 is 2. Here we have 3 times 2, which is 6, and 0 times 2, which is 0. And then we have 4 times 2, and 3 times 2, which is 6. So when we go to graph this new point, or these new points for our new image, there's A prime, there's B prime at 6, 0, and 8, 6 is up here, C prime, which gives us a new shape which should look exactly like the old shape, just twice as big. So a few things to notice. Here we have this side B is, or not the side, but the distance of B from 0 is 3, and the distance to B prime is 6. So it doubled because of that factor. We can't measure, or we could measure, but we can't tell exactly, but the distance from 0, 0 to A is half the distance here. So this gets, again, doubled. And it works with C as well. It's twice the distance away from 0. So not only is it twice as big, it has moved out twice as far from this point of dilation. Okay, so again, you can pause the video and try this one. This one has a scale factor of 1/2. All right, welcome back. So if it's a scale factor of 1/2, you should ask yourself enlargement or reduction. It's a reduction because it's between 0 and 1. And to make our new points, we're going to multiply these values by 1/2. So -4 times 1/2 is -2. -2 times 1/2 is -1. -2 times 1/2 is still -1. 4 times 1/2 is 2. 4 times 1/2 is also 2. And 0 times 1/2 is 0. So we get -2, -1. There's our A prime. -1, 2. There's our B prime. And 2, 0, which is our C prime. And you can tell this triangle is definitely smaller. So it definitely was reduced. And just like in our previous triangle, the sides were all twice as far from 0. These are half as far. So C was 4 units away from 0, and C prime is only 2 units away. So that distance was cut in half. And the same thing goes for here, this distance, and then here's half. And same with B, the full distance, but this one's half. Okay, and then our last example is what happens when our scale factor is negative. So it's not larger than 1, and it's not between 0 and 1. So I didn't cover this in the beginning. So we're going to see what happens. We're going to use our same method by taking each of these points and multiplying them by our scale factor. So -2 times -2 is 4. 0 times -2 is 0. 2 times -2 is -4. 3 times -2 is -6. 1 times -2 is -2. And -2 times -2 is 4. So when I go to graph these, 1, 2, 3, 4, 0, there's A prime. -4, -6. Here's B prime. And then C prime is at -2, and then 1, 2, 3, 4. So, would we call this a reduction or an enlargement? First question. Draw it in while you think about it. Hopefully you came up with it's an enlargement. It's quite a bit bigger, so it's an enlargement. So the 2 definitely made it bigger. But something else happened. It also has rotated around the origin. So if we measured our B length, our B prime is twice as far away. So it is twice as big, but it's in the complete opposite direction. So if we look here, we've got B going this direction, and B prime is in the exact opposite direction. And on a graph, when you're in the exact opposite direction, that is a 180-degree rotation. It's not a reflection, and we can tell it's not a reflection because if it was, our A point and our C points would reflect this direction. They would reflect straight over, but they didn't. they've switched sides. So this little triangle here has actually rotated around and then been enlarged. And that's the end of the lesson.